Hello people, this video segment is for Chapter 3, which deals with modeling of a universal joint mechanism in Catia. So let me show you first what the plan is. I would like to create this mechanism, and I think it's instructive for me actually to make the parts, although they are simple, but I think it gives a good idea of how I go about doing this problem. Making the part probably takes about 4 or 5 minutes, and then we put it together as a mechanism. Okay, so let me, ignoring all the dimensions, let me start with the product file. So file, new product, and right away I'm going to save this thing. File, save management, save as. On my desktop, I create a new folder, and I will call it universal joint universal joint mechanism. Okay, the first thing I'm going to do is create an orientation part. Its sole purpose is to make sure that when we create these shafts of the universal joint, we can easily position them. So insert a new part in there, and I will call this thing orientation. Right click, properties, orientation. It has no other function. Orientation. Okay, let's make it. So double click on this. On a convenient plane, on that vertical plane, I will draw a broken line segment like so, where the angle between them is between these two lines is 60 degrees. This is the angle of the two shafts, as you will see later. So let's make it 30 degrees. All right, good. Exit, and obviously save it. Let us now go and make the shaft. So insert new part in there. I'll say no, and right click, properties, shaft, and shaft. The two shafts are identical, so I will make only one of them and use an instance of that for the other piece. So let's make it. On a convenient plane, for me this vertical plane is convenient. I'm going to draw the grip of that of the two shafts. We'll clean it up in a second. Something like this. I'm going to make it nice and symmetric with respect to the horizontal axis. So this line, control that line, control the middle axis, symmetric, and this line, the bottom line, and the middle line, and symmetric. Okay, since there are no dimensions specified, these can be resized until we're happy, and this looks good. Exit, pad it in both directions, and let me make this thing point maybe 0.4. Okay, yeah, that looks fine. Okay, now on that top plane, I will draw a circle because you want to make a hole so that the crossbeam is going to be positioned in it. So, you know, something like that. Exit. Make a pocket all the way through into the last. All right. Now let's make the actual shaft at this end. So let's draw a circle. There we are. Exit and pad it to the length that we are satisfies me. So this is going to be, yeah, that's fine. Let's make it 5. All right, good. Now, for a reason that becomes clear in a few minutes, I would like to create a point exactly halfway between the center of this circle and the circle underneath. So let's create a point here. Where are the reference elements? There is a point. And the way we want to do that, we want to say between. Well, it's going to ask us between what point. So, okay, I want to create a point at the center of this top circle. So right-click, create a point. And the method of creating the point is center of circle or ellipse. So there is my circle. So notice that it temporarily created a point there. And then it's asking you for the second point. I do exactly the same thing, create a point. And for the circle, I'll take this bottom one. Again, temporarily creates a point there. And it says, okay, you created your 2 points. Where do you want the middle point to be? Obviously, it's exactly halfway. So either I can say middle point or put 0.5 here. It'll do the job. So notice that it did create a point for me. It's right there, as you can see. And I will be using that later on for the purpose that I have in mind. Okay, so let's save everything. I can insert the second shaft because I saved it. I can say insert existing component in there, and I go to that folder that I created. I think it was called Universal Joint. Let's see if we can find it here. Let's see now, this one. This is the one that I created, and I called it shaft. I bring it out, and the two are going to be superimposed on top of each other. The two are sitting on top of each other, so we can actually, let's see now, we can move these things so that they don't interfere with the rest of our work. Might as well rotate about the z-axis. Oops, there we are. And also translate it in this direction, because later on I'm going to mount it on that other end. Right now it's not that critical, but we're going to do that later. Alright, so let's actually go ahead and do the pin. So save everything. Insert, new part. Say no. This is the cross pin. So I'm going to call it right click properties, cross pin, and cross pin. Alright, and let's make it. So on a convenient plane, on that top plane, I will sketch. I want to sketch a circle that size, so why don't I just project that circle, one of these circles. There we are. See, right there. Exit, and then we pad it. And we pad it until the bottom plane, until the plane up to this plane, and the plane is right there. Okay, so that's the half of the cross plane. Now, to create the other one that is perpendicular to that, I will use this trick of making a circular pattern. 2 instances, total angle is 90 degrees. And the thing that I want to pattern is that path. And the reference element means what is the axis of symmetry type thing. So either you take the axis of the shaft or this line, and notice that it did create it over there. Okay, that's an easy way of making this whole thing. Alright, so let's actually go ahead and save everything. So let's go to the top level assembly. That's my favorite way of doing. Save everything. Alright, there are no assembly constraints here. So let's actually move stuff out of the way. Let me move the cross pin out of the way. I'm going to translate that in the Y direction. There we are. And there is no constraint, there is no assembly constraint between the shaft and this line. So I make a coincidence between the axis of the shaft and this line that I created, orientation. Remember, orientation that I created. Actually, not that one. Oh, sorry, the other side. So undo this, start again. Coincidence between the axis of the shaft and, let me see, okay, there. This is the piece of the orientation on this side. Nothing is updated, nothing is there to update because that was already, they were already coincident. Okay, now I also want to push this point to that center point. See that? This point that I created here, I want to put it exactly at the break line. So coincidence between that point and this origin. And update, so it's going to push the this shaft to the left. Now let's insert a crosspin. So coincident between the axis of the pin and this, and also coincidence between the axis of the pin here and that guy. Coincidence between the axis of the pin. Well, actually, let's and let's not worry about that because I have to do that after a. Let me update this. There we are. Okay. Don't worry about the other one right now. So let's place this other shaft on that orientation line. So coincidence between the axis of the shaft and this, and update. Good. And then coincidence between this point and that point that is right at the break point, and update. So all I have to do is to make sure that these are lined up. Coincidence between the axis of this hole and the axis of this crosspin. And by the way, I forgot to do something it makes it a lot easier if I anchor something. So I'm going to anchor the orientation right there. Okay, and now update. All right, good. Excellent. So this is pretty much it as far as making the parts is concerned. So let's save everything. And now we go and do go to the digital mockup. So digital mockup, DMU kinematics. Get the magic wand out. There's a magic wand. So the joints that we created, we're going to convert them into the constraints that we created. We're going to convert them into joints. So new mechanism, auto create. Okay. Now let's check what we've got. See what we've got. We got several cylindrical and one spherical. The reason that we have a spherical is that we put the 2 points coincident to each other. So first of all, I don't need this. Delete. All right. And what I would like to show you is something interesting, and that is well, first of all, degree of freedom, it says it's 1. Okay, so let's see now. Let's take one of these. Let's take one of these and make it angle driven. For example, we take let's see now, this is shaft 1. The cross pin is shaft 1. Shaft 1, cross, shaft 1. This is shaft and orientation. That is this guy, as you can see. Make it angle driven between 0 and 360. It says mechanism can be simulated, and let's try it now. We can do that manually right there. You see, we have the universal joint working, and you know, this is fine. We did it, but I never actually used this universal joint that you see here, right there. Okay. This thing works. There's no problem, and I can put physics in it. But the question becomes, what is the purpose of this universal joint here? Okay. Now notice that the role, this cross pin, really its role is secondary here, because if you want to make sure that motion is transferred from this shaft to that shaft, according to the laws of physics, according to the laws of universal joint, then we really don't care about that pin. As a matter of fact, I can go and entirely delete the cylindrical joint between the pin and these shafts. So let me delete this, and let me delete the other one right there. Delete the other one. All right. Obviously, the degree of freedom is 2 here, and it won't simulate. So now I can use this universal joint icon here, and for spin 1 I select the axis of this shaft. For spin 2 I select the axis of the other shaft, and you can leave these things the way they are. It's really not critical. As a matter of fact, the documentation about the meaning of normal to spin 1, normal to spin 2 in the online documentation is pretty bad. And in fact, if you try to find references to this terminology in textbooks or research books, you don't see anything. So I'll just leave it the way it is, and it works without it. And look what happened. So mechanism can be simulated. Okay. So let's see now. For example, right there. Except that the pin will not move. If the motion of the pin, cross pin, is not important to you, don't worry about it. Just create 2 cylindrical joints. In this case, one is revolute, the other one is cylindrical. Depending on how you do it, it could be that these are both cylindrical and universal joint will do the job. Okay, so